Right. In this video presentation, I will be looking at 2019 Add Math. All right. So definitely I'm looking at question 1 in this episode. Thank you. Stay tuned. I will be right back. And I hope that you will enjoy, you will learn. Please subscribe, leave a comment, and share this video. Thank you. So the question reads here. All right, so the question reads, the function f is such that f of x is equal to 2x cubed plus 7x squared plus 3x. Question 1, part 1 says determine the linear factors of f of x. And when we talk about linear factors, you're talking about when the variable is raised to 1 to the first power. So we're looking at this. Let me rewrite this. We're looking at 2x to the third plus 7x squared plus 3x. Technically, what we want to do is to factorize this. So in factorizing this, we will get out the linear factors. Definitely, I'll start off this by looking at the highest common factor, x, which is the factor for everything. And then in so doing, I'll have 2x squared plus 7x plus 3. And then what I'm going to do with this part here, definitely, I am going to factorize this using the AC method. But definitely, we could just look at this quickly. We're talking about having two brackets, right? We'd have a 2x, we have an x, and that will give us a 2x squared here. I need a 7, so I'm going to have a plus 1 and a plus 3 here, so that you're having x, open bracket, 2x plus 1, close, open, x plus 3. These are the linear factors. In other words, if you multiply all of this, we will get back our original thing. And with this, I believe we'll get about 3 marks for that. As you could see down here, 3 marks for that. All right, let's move forward. Compute the roots of the function. All right, so in order to find the root, what we really want to see is when this function, matter of fact, if we look at this quickly, the roots of these functions would be function actually crosses the x-axis, should say. Then that is when the y is equal to 0. This is when y is equal to 0. So we want to know what happened at that location, those places. So quickly, what we're going to do is just definitely to equate x times 2x plus 1 times x plus 3, and this must be equal to 0. And if this is the case, we can say, guess what? Either x is equal to 0 or 2x plus 1 is equal to 0 or x plus 3 is equal to 0. So in this case, any one of these would be the possibility or the possible reasons why everything multiplied to 0. This one, though, is finished. X is 0. We're going to solve these. Let me change my pen ink quickly. So in solving this, I'll subtract 1 from both sides here. So I'm looking at 2x is now equal to -1. Solving for x, I'll divide both sides by 2. So I'm looking at x is equal to -1/2. And here I'll subtract 3 from both sides. Definitely x is equal to -3. Here are the roots. We have 3 roots, and here they are. X is equal to 0, x is equal to -1/2, and x is equal to -3. Part B is a function, right? And so part B says two functions are such that g of x is equal to x squared minus x and h of x is equal to 2x minus 3. Definitely we're asked to find or determine g of h of x. This is a composite function, all right, where the h function is actually going to plug itself in the g function. So let's write the g functions for start. G function for start. So here it is. G of x is equal to x squared minus x. So what I'm going to do here is that I am going to insert the h function in the g function. That means I'm finding g of h of x. Therefore, wherever I have x, I'm going to be plugging in the entire h function. So x squared would have meant 2x minus 3 squared minus, and I'm going to put this in a bracket, 2x minus 3. So this is what we have, having allowing the h function to be operated in the g function as an x. All right, so what we have here is the square of this binomial. When we square a binomial, we square the first term, so we're looking at 4x squared. We multiply the terms and double it. So inside, so 2x minus 3, when you multiply that, that's negative 6x. You double that, you'll get negative 12x. And then we square the last term, negative 3 squared. Anything square is positive, positive 9. We're going to distribute this negative sign in the bracket. So we have negative 2x and then a positive 3. So we have to look out for stuff like that. Let us group our thing and organize it. We have 4x squared, negative 12x, negative 2x, that's negative 14x, and 9 plus 3, that is definitely 12. So this response is for g of h of x, all right? So g of h of x is 4x squared minus 14x plus 12. And you would have gotten those 2 marks right there. Given that h of g of x is equal to 2x squared minus 2x minus 3, show that the value of x for which h of g of x is equal to 0 can be expressed as this. In other words, you're telling me to express this as that, all right? No problem. Therefore, we're going to let 2x squared minus 2x minus 3, we're going to let this equal to 0. That's what this said. All right, h of g of x equals 0. This is h of g of x, and yes, it's equal to 0. Having said this, though, to get it in this format, I'm seeing the quadratic equation coming out. So let us list what is a, what is b, and what is c, because we're going to definitely substitute these in our quadratics formula. A is the coefficient of the square of x, it is positive 2. B is the coefficient of the x, and this is negative 2. And c is the constant, which is negative 3. What's the formula? The formula says x is equal to the opposite of b, or minus b, plus or minus the root of b squared minus 4 times a times c, and all of this must be over 2 times a. In an effort to substitute, we're going to have minus b, and b is a negative number. I'm going to just put it in a bracket so that we could see, plus or minus the root of negative 2 squared, all right, minus 4 times a times c. All right, so there we go. And all of this must be over 2 times a, and a is 2. All right, let's go. Could I put it by the side there? I'm going to put it at the side here as we go. All right, so this is going to be a positive 2 when those two negative signs clash right there. We're looking at 4, and when we multiply this, we'll get positive 24 all over 4. Let me take it back here. All right, let me give myself a little bit of space just to work. All right, let's go. All right, so we're looking at this, which is 2 plus or minus the square root of 28, and this is over 4. I'm not sure what kind of 4 I was writing there. All right, let's push further. So 2 plus or minus. I need to manipulate this 28 using the radicals, but guess what? There's a perfect square for that, which is the root of 4. So the root of 4 times the root of 7 is the same thing as the root of 28. All right. So I was able to get out this the root of 4, and all of this is over 4. Let's go further. In simplification, we're looking at 2 plus or minus the square root of 4 is 2, and then we have times the root of 7. My answer is now coming to what I want, all over 4. What I'm going to do here, I'm just going to do it right here. I am going to, so x is equal to, I am going to factor out this 2 here. I am able to factor out this 2 because I'm seeing where I have a common factor of 2 there. Open bracket, 2 into itself 1 time, and then 2 into itself 1 time here. So I'm not going to write 1 root 7. It's just root 7, right? So as you could see, this is what I have now. And all of this is over 4. At this point in time, we can definitely see where canceling could take place. 2 into itself 1 time, 2 into the 4 2 times. What am I left with? I'm left with the fact that what we do have here is 1 times this is 1 plus or minus the root of 7 all over 2. Hence, we have proven that x is proven to be 1 plus or minus the root of 7 all over 2. Has it had suggested here that we were looking for this, and definitely you saw that we proved that. All right, good. Next question. It says solve 3x log 2 plus log of 8 to the x equal to 2. We want to find what value of x, all right, could produce that. Let me write this quickly. This is what we were asked to solve. 3x log 2, and we're adding log 8 to the power of x, and this is equal to 2. So this is what we want to solve. What we can do though is to apply our laws of indices and the laws of logarithm, because solving logs is just to make sure that you remember the law. So let us go. What I want to do now is to represent 8 as 2 to the 3rd. So I'm going to be utilizing one of the laws of indices here, representing 8 in an exponential form. Basically, that's what I meant. Representing 8 in an exponential form, so it's 2 to the 3. So in rewriting this, I have 3x log 2 plus log 2 to the 3rd power. I'm going to put this in a little bracket and then put the x outside, and this is equal to 2. All right, so basically this is 8 to the x. Now let us say we have a to the m, and this is raised to the n. The result for this is a to the mn. In other words, when a power is raised to a power, we can multiply the powers. So let us utilize that here. 3x log 2 plus log 2 to the 3x, which is equal to 2. So I just utilize this here. All right, so we have that. Now, another one of the log rule is that if I have log of, say, a raised to the x, it can be represented as x log a. So I'm able to get the exponent as a coefficient of the log there. So definitely, let's rewrite this. So we have 3x log 2. Then now I'm going to bring this part forward. All right, let me just circle this very quickly for us. I could just highlight this very quickly. I'm going to bring this part, all right, this part, I am going to bring it down here, all right? So in rewriting that, this is what we have right now. We have that 3x coming here, and then I have my log 2, and this is equal to 2. So basically, it's like utilizing as many of the rules as you can remember. Now let's think about this. If I have 3x log 2 2 times, it simply means that I really have 2 times 3x log 2. That's what this really means. So basically, it's 6x log 2. All of this is 6x log 2 because it's 2. This is linked to this concept. So this will become 6x log 2, which is now equal to 2. I'm almost at the end because I'm in search of x, so I could divide both sides by the log of 2. All right, so it is 2 divided by log 2, and then you could see those cancel there. And then ultimately, I'm getting there. So basically, I'm left with 6x, which is equal to 2 over log 2. Finally, I can multiply both sides by 1/6 in an effort, or we could say to divide by the 6 is the same thing by multiplying by 1/6. So we could see this cancel, leaving my x here. definitely I'm going to put this out front like a coefficient, log 2. And then I could cancel 2 into itself 1 time, 2 into the 6, 3 times. So finally, x is equal to 1, and I have 3 log 2, and that's my answer. We call it my 4 marks there. All right, so definitely we are good here. Thank you for watching. Please subscribe to this channel, leave a comment, and share.